My name is Mike Sheely. I'm with Goldenor. Goldenor has been a partner of Oracle for about 10 plus years. And the conversations that we're having today are really around standard analytics, traditional analytics, and stream analytics. And the conversation, we know that companies has massive amount of data. Mass data is coming from all sorts of sources. That data is being transferred from sources to target. There's analytics done on it. There's visualization on it. There's reporting on it. And then decisions are made and business outcomes happen. With stream analytics, all those analytics and decision making happen in the moment in real time. Here's a good high level overview of how the difference between stream analytics and traditional analytics look. You can see that in traditional analytics, there are different things that happen as the data moves through the system, but it does result in a business outcome for your benefit as a corporation or as a business. In stream analytics, all that decision making and analytics is happening in the moment as the data is in motion and transiting to the targets, giving you the ability to have real time decision making that gives you on the fly decision making and increases your revenue, decreases risk, or increases the customer journey. So there's lots of different ways that you can use stream analytics. And in the webinar, we're actually going to go in depth on a successful deployment of stream analytics that Goldenor had in a bank in Poland and the business outcomes that that bank realized. There are a lot of other different use cases that we're exploring with different companies. And while you're reading through these, let me give you an example. Say a customer goes into a big box store, and that alone might be the trigger. With geolocation, you may then understand that that customer, your customer, has entered into that location. And using all the data sources that you have about the financial history, the purchasing history, the credit history, maybe even social sentiment, you can take that information and create an offer specific for that customer. That may be the only trigger that you need to generate net new revenue or increase the customer journey through the process. Another trigger in that example might be when the customer swipes their card. Now that you see that they're buying a pretty large purchase, maybe it's a TV. So now with that information, you can do even more specific offers. It could be a buy now, pay later. It could be additional loyalty points. You could even offer them a different product. Maybe they use one credit card that doesn't have benefits and points. So you could offer them at that moment another credit card that offers points and benefits. So you can see that stream analytics, it's about the timing. We know that timing is important when you're trying to generate new revenue streams because information, but by the time the customer gets the offer, they've already left the store. Maybe that they're at home. So with stream analytics, you're able to actually do on-the-fly decision-making based on the analytics of your data in motion. So as I introduce the speakers for today, think about where in your business having access to data in motion, events that are taking place, actions that are taking place in real time, being able to apply machine learning and AI decision-making capabilities to create business opportunities for you or customer experiences for your customer. Think about that as you listen to the rest of this presentation. Where does that instant analytics and decision-making capability apply to your business and add value? So today's speakers, we have Alex Kotopoulos from Oracle, Pete Inzana from Oracle. They'll be going through the Oracle Stream Analytics overview with some live demo screens as well. And then we're going to transition to Bartłomiej Wązlowski. He's going to walk us through a use case where Goldenor successfully deployed Stream Analytics and had saw real business value for a bank. If you have questions that you want to ask, use the Q&A process, and Sebastian and Pete will be answering those in real time, almost real time, just like Stream Analytics as best they can, and we'll get those answers to you as quickly as possible. In the meantime, let's get ready for Alex. Alex, are you ready to go?
I am ready to go. Hello, everybody. So I'm going to talk today about the Oracle Golden Gate family of products, our ability to perform streaming data integration and analytics, and to create with it a modern real-time data platform for data fabric and for data mesh use cases. So I'm a product manager within the Golden Gate team responsible for streaming analytics. And when you talk about data mesh and data fabric, those are buzzwords right now that are used a lot, and what's actually behind it. When you look at these terms, at the core of these terms are the fact that data is produced in modern enterprises in specific points by specific data producers. And this data is consumed either by internal customers, other departments, by partners, or by customers. And instead of centralizing everything, we want to decentralize it and also make it real time. So these are different goals that we have with our overall data mesh and data fabric. As we have consumers and producers, the overall term that is becoming fashionable is data products. You want to look at your data as a product that you can monetize. Just as Michael just said, that the information can directly be used to upsell customers, to cross-sell, to provide them in the moment with capabilities, with either providing revenue immediately or by providing additional value that is there. So, for example, fraud prevention or overall preventive maintenance, a lot of things that you can do in the moment as data comes in. So we at GoldenGate, we are providing an overall data fabric to deal with real-time information, to both analyze it and to also store it, for example, in data lakes or in data warehouses for future consumption. And with this, the overall GoldenGate platform has a lot of different sources and targets. GoldenGate can reach from a variety of databases. We can capture from all major databases, non-SQL databases, big data, event platforms, or also IoT or sensors. So all this information can be directly used to be analyzed and to be stored and forwarded into a variety of targets. So you see that GoldenGate, which is the market-leading data replication tool, together with GoldenGate Stream Analytics, provide this good combination of capabilities to manage your real-time data. As an example for multi-cloud data fabric is, for example, American Airlines, which takes data from a variety of sources, for example, legacy transactional applications, getting it into their Oracle Cloud applications, where you use your loyalty program and you have the data not through batches, but in real time. So data is passed through as it happens, as the transactions hit the core mainframe applications, the core legacy applications, and are passed through upon and are even transferred between different clouds. So it's not just Oracle Cloud, it's also Azure Cloud. You can do analytics in different ways, and it doesn't need to be a pure Oracle environment. That's a big part of it. In today's world, you rarely have a pure monoculture of one company. You have hybrid environments, and that's something that we work with, where we are distributed environment with a hybrid cloud, multi-cloud environment. This is something that we thrive in. If you look at Stream Analytics itself, you can think of it that you have a number of different sources coming in. You get data from IoT or sensors, or maybe from mobile apps telling you, okay, this user used its mobile app and this is the location of the user. We can also have transactions. We can work with the major transaction systems, with banks, so we can basically benefit from the stream of transactions going into a core banking application. We can deal with a stream of data from other transactional. So, for example, as you saw, transportation industry, and we can integrate with GoldenGate. A lot of users already use GoldenGate in this capacity. So you can just listen to the stream of GoldenGate transactions coming through and basically use Stream Analytics as another consumer. Finally, we can work with applications if you're working with your overall business applications, and these can also send out events, and we will work on these events. So we have live streams coming in, and with this live data, we can do a lot of different things. We can filter the data, we can normalize it, we can enrich it. So often these events are very sparse. They just have maybe a few measurements and an ID, and now we can look up the additional information that we have stored in our databases, in our systems, and learn more about this event and add more information about the customer, for example. We can aggregate the data. We can, for example, take very fine-grained events that come in millisecond intervals and then, for example, aggregate them every second, every minute. We can create averages. We can see the spikes within the data. We can also work with the geocode information within the events. For example, as data comes in from vehicles, comes in from mobile applications, we don't just know what's happening, but where it is happening. We can correlate the information that multiple events who happen in a certain time period within a certain order means something special. So, for example, something was forgotten, that we can find that out because it goes somewhere and doesn't come back. Those are things that you can correlate, identify the information, and with machine learning and with AI, we can predict. We can take certain data and we can make an assumption, we can make a prediction, which is very useful in terms of fraud detection, in terms of preventive maintenance, and also in terms of marketing with individual customers. And based on this data, we can either visualize it through the visualization capacity within the tool, can visualize it external to the tool, we can drive actions. So like what we saw from Michael in his earlier slide, we can directly, without any human intervention, drive an action, for example, send out an offer to a customer, freeze an account, do all different kinds of immediate actions based on the data in near real time. And finally, we can take this data and we can pass it on, can make this a real-time transformation engine, a real-time ETL engine that takes data in real time, transforms it, processes it, and then stores it into a target, such as a data lake or a data warehouse. So a lot of different options that you have in Stream Analytics. And I'd like to jump into a demo now, just to show you how this looks within the tool, what we can do within the tool. And this demo is about a targeted promotion for customers within a movie streaming business. So think of it like Netflix or other movie streaming businesses. People are watching movies, and we're working together with a national jewelry chain as a partner, and they want to provide promotions during Valentine's Day, which is coming up in a month. So it's actually timely, and they want to provide them invitations to exclusive events. When they select a movie and when we determine that they're actually in the market for jewelry, when they are a potential customer, and finding out whether that's the case, that's the trick that we want to solve within the streaming pipeline. And looking at the architecture, we're using Golden Gate replication in order to get transactions as they happen and passing them on into our cloud-based Golden Gate and cloud-based Golden Gate Stream Analytics. And while this is all happening on the cloud, we can deploy this in different environments. So Golden Gate, as well as Golden Gate Stream Analytics, runs equally well in on-premise environments, as well as in Oracle OCI Cloud, but also in third-party clouds. For each one of them, we have a strong customer base, and we can also work across these different environments, as you saw in the American Airlines slide. So we're taking the data, we're putting them into Stream Analytics, we join the data. We also work with the geospatial information in order to determine whether a customer is within the right geographical area, because we don't want to invite them if they are not close to any event. And we also want to use machine learning and scoring in order to determine that based on their movie choice, based on their overall demographics, they're actually a candidate for our promotion. Once we have done the scoring and we filter out all the candidates, we send them an invitation, but we also store the data in our autonomous data warehouse so we can do further analysis in the future. So without further ado, let's take a look at the demo. So here we're looking at the Oracle OCI Cloud. We're within the Golden Gate environment. And within our Golden Gate native service, we have the concept of deployment. So a deployment is a logical entity that you use in order to run your application. So you create a deployment and then you can scale up and down the deployment in order to run your streaming application, your data replication application. And so we're ready to create a deployment. So I'm just pressing the create button. It creates a deployment, so you don't have to deal with computers, you don't have to deal with VMs and all that comes with it. It's all automatically done. So now we have a stream analytics deployment. We can see that it has assigned connections and we can launch the stream analytics console. So you see here, this is the base interface for working with streaming pipelines, and you can see a number of different resources here. You see we have pipelines, which is the core concept of stream analytics. So everything goes in a pipeline. We have sources putting data into a pipeline, and the pipeline processes the data and writes it out to targets. And everything else supports these pipelines. So all these other elements are part of to basically build up this pipeline. And so as we are seeing these different types here, the pipelines, the streams, the references, these are all used in order to, for example, define your sources, define your targets, and also to capture from Golden Gate. So here we have a Golden Gate change data environment. This will, I mean, if you're familiar with Golden Gate, we have replicates that extract data or extracts with that extract data from sources, listen to transactions, and we have replicates that write the data onto the target. And as any transaction happens on the source, it gets forwarded to the target. And we can latch on to any existing extract in a Golden Gate environment and read the data. And we can use this as change data that will then be events in our pipeline. So we do this here through Golden Gate change data. We're creating this. It automates a lot of the Golden Gate configuration. And once we have that, we can go on. We can take this data. We can put this into a pipeline. And what I'd like to do is I'd like to create a pipeline from scratch here, just to show you what the general idea is of creating a pipeline. So I'm just giving the pipeline a name. I'm picking the stream, and this stream is just the transactions coming from Golden Gate that we just got through the change data object. So now we have a stream of transactions coming in, and just having this little wizard dialog will create us our first running pipeline. It doesn't do anything, but we can already see the data. So you have this input here, and at the bottom, you see all the events coming through. So as we're listening to the events, you see here, we have these streaming events of customers watching movies. We see the device, we see the app, we see the movie and genre ID, customer ID. We only see IDs. So without enriching this data, we're not really knowing what's going on. So because of that, we want to join the data with what we know from our databases. We know about each customer based on their ID. We know about the movies. So we're building a join together now. We have used the customer here in order to join it with the stream. This is a customer table in our database. And now we're building up a correlation condition, which is pretty straightforward. We take the customer ID from the database, and it's equal to the customer ID in the event. So no writing SQL, just putting together a correlation condition. And then at the bottom, you see color-coded the additional information here. You see the technical event linked with the information that we know about a certain customer. So now we're also adding a pattern, and this pattern is a spatial pattern. So now that we have enriched the data, we want to filter out any customers who are outside our geographical area. And at this point, I'm jumping over to the actual created pipeline, the called movie promotion. So you can see how an entire pipeline looks like. So we already saw the join in our little example. And now we do the same thing with not one, but 3 different tables. So we have it very enriched. You see a number of different colors that we have enriched. We then go into a geofence. And so looking at the join, looking at all the events coming in, now we know more info about the movies. What is the name of the movie? What is the genre of the movie? All of this information is useful, for example, as input to our machine learning model later on. We then go to the geofence. We can use the geofence in order to filter our data, and we can do that. We're going now to the geofence map, and we've already pre-created a little map. Rather simplistically, you can draw it here as simplistic as you want. This was based on a tutorial, so we kept it simple, but you can do it as sophisticated as you want. And also you can get the data through geospatial objects from the database. So you don't have to draw it yourself. Drawing makes sense for simple environments, but you can have thousands of geofences that you store within the Oracle database. Now that we have these additional promotion areas, now we can filter out only customers who are within those areas. And you can look at the map and see that only customers who are in the given areas will be forwarded and will be further analyzed. You see within the data that flows through the place name, the areas that each customer is associated with if they are filtered through. Based on this, the next step is to actually score machine learning. And for this, we are going to Oracle Machine Learning, and we are using AutoML in order to automatically train and use our machine learning model. So we have in advanced, we have trained a model through AutoML just by entering training data. And this model, I'm not going to go too much into detail here, is used through this by connecting to the Autonomous database and scoring each event. So as we're scoring each event gets a numeric value, and we're filtering out only numeric values which are greater than a threshold, which means if the numeric value is higher, that means the person is qualified in order to get a promotion. We also can then add additional charts, so we can actually analyze this data as it comes through. And this is really useful and important, not just for the end customers, but even for the developers to see, okay, we know that our system is working as expected. So you can directly get feedback on, do your numbers make sense, or is this something that still has a development error in it that you need to fix? So this helps us to expand the circle of people who can work with this, who can creating pipelines, who can change pipelines. Previously, streaming pipelines were often very much programming efforts, and you would, as a customer, you would have to program in languages like Scala and PySpark, and only skilled developers would be able to create stream analytics pipeline, to maintain stream analytics pipelines. With this, we're able to up-level it so that also business users can understand the pipelines, can modify the pipelines, can introspect the pipelines, and it's no longer just an pure programmer environment. So to summarize, you've seen the key capability of stream analytics. Most importantly, I would say, is the ability to self-service and no-code, low-code ETL pipelines, so that everybody can understand it, can make changes, can for example, adjust pipelines, change values in it, add additional scenarios, and the further you go, I think business users can create pipelines and can modify them, which is really useful in an environment. We can analyze time series data. We can find anomalies, can find missing data, duplicate data, and act on it. You can see real-time dashboards. You can see real-time charts, not just within our tool, but also in combination with other tools such as Grafana or Oracle Analytics Cloud. You can do rule-based decisions. We have a rich collection of patterns that have already pre-created all the typical algorithms. You can do geospatial analysis, and finally, you can do predictive analytics and machine learning, which is really important in order to make automated decisions. So that was a quick run through all the capabilities of the product, and I will pass it on now to the next speaker. Thank you.
Okay, Alex, thanks a lot for the presentation. Now it's my turn to tell you a little bit more about the project we delivered as a golden or for one of the Polish retail bank. Just give me a second. I'll try to share my desktop. We'll see that it's okay. As said previously, this in fact is one of the first Oracle Analytics project implemented in Europe, and especially this one only. The customer is a Meteor Polish Universal Bank, which has about 4 million customers, but is a very, very innovative bank who would like to implement a lot of interesting solutions. And the project goal, especially the stream analytics and the event stream processing, was a part of the large transformation of the retail customers banking experience with hyper-personalization. The CEO Bank decided to deploy the very specific and very advanced tools to diagnose customers' needs, to try to provide one-to-one personal marketing communication to customer, the tailor offers for each of the customers. Then look and hear for some specific signals within the real time, trying to adapt the communication from the bank to the customers by the changing of customer needs. And at the end, the bank also would like to align communication with every channel, every contact, every day, to adopt communication with the customer with the specific needs and specific time and specific capabilities of each customers. It was the idea of the program. This program is not only regarding the stream analytics, but also several other systems and the technologies. But this is the core, and this is something which drive these whole initiatives with the bank for about 1 year. What was the project summary? In fact, the RFI was released in April 2022. For us as a Goldner, the customer was a completely greenfield. We invited because Oracle suggested us as a great company knowing Golden Gate quite well and will be able to provide good support and implementation. We were invited for a running proof of concept for the 3 use cases driven by the business CRM division of the bank. And then we were selected as a formal RFP. The RFP was really huge. It was 8 areas, almost more than 400 specific conditions regarding not only the technical capabilities, but also about the business capabilities of a solution. We were selected at the end of 2022, and the agreement was concluded in the February. Project was delivered in more about 19 slides. We go live because of the banking strategy. The live was postponed for several months, and we go live in July 2024, and now are providing some kind of ongoing support, helping bank to develop the solution further and then provide technical support for the customer. What was the details of the project? At the initial phase 1, the customers would like to implement only 4 input topics. It was and 3 output. It was mostly Kafka. In the meantime, bank is trying to also add additional topics regarding the XML for the communication with the legacy systems, and the Golden Gate for communication with the databases, not only Oracle, but also others. And as an output topic, we are doing the batch and the Kafka also as a output topic. Bank started project with the 13 events with beginning performance at the 12,000 transactions per second. Finally, within the 5 years, bank wanted to reach the level of the more than 500 events, and the estimated performance of the whole system was planned under 330,000 transactions per second. In fact, due to the very, very fast development of the solution, this performance is already delivered, but bank is not using it completely. This is potential capabilities, but bank is still using about 100,000 transactions per second only. What is most important, the project was run only for the CRM department and for the line of business people without IT literacy. As Alex previously said to you, the system is well suited and well crafted for the line of business people without knowledge of the SQL, knowledge of the programming skills, only drag and drop. And this is extremely useful and extremely easy to understand and learn for the business users. From the customer project team was 20 specialists. It was mostly IT people connecting the systems, Stream Analytics to the different bank systems through Kafka and other integrations. And there are people from the line of business which are implementing the pipelines. From the Golden part, 5 people participate in the whole project. We used, by decision of the bank, we used OSA as a Stream Analytics as a major tool. And we also used Cloudera, Spark, and Confluent Kafka as communication and the runtime. What's most important that the Stream Analytics is using Kafka. It could be Cloudera, it could be Confluent, it could be vanilla Kafka. As a runtime is a Spark, which is extremely easy with this respect to it. It's extremely easy to go through and make the environment bigger and bigger with the limited investment into the licenses. From the system perspective, we are using virtualization on Oracle for databases in the solution and the Red Hat. Enterprise Linux with VMware. At the end, customer decided to run the Spark nodes on the physical hardware due to the performance capabilities that the bank wanted to achieve within the near future. What was the major business drivers for this project? Of course, it's easy to understand that the most important was increasing of sales revenue, and it comes mostly from the cross-sell and upsell. The first pipeline the bank launched was the buy now, pay later initiatives, that the bank monitor every credit card or every card transaction, and if the transaction was higher than 10% of the overall monthly spending of these customers, the banks was sending specific proposal through the SMS or through the push on the mobile banking, dear customer. We truly appreciated your continuous business with the bank. If you would like to, we want to provide you the BNPL proposal. You can not pay right now, but within 30 days without 0% rate. If you're interested, say yes. Send us yes with SMS or with the mobile push, and we will do these kind of transactions for you. It was the first use case, but the currently bargain trying to react for the more specific signals to providing the loans, credit card extensions, or the overdraft or the banking account to run the cross-sell and the upsell, especially revenues. Also, the value-added services or regarding some kind of package of the banking proposal are analyzed through the whole transaction the customer is doing with the bank and behaviors of on the mobile banking application or the web banking. And with respect to that, the bank is proposing some kind of bundle packages. For example, if you are a heavy user of the banking services, we propose you the golden account, which includes, for example, 100 free of charge money transfer or specific interest rate for the deposits, or the bonus. Would like to extend your relationship with the bank, we can propose you specific kind of proposals. For example, using the geolocation, as Alex showed recently, the bank implemented some kind of special program for the customers who are doing transactions in the shopping mall. And if these transactions are between the 11 and 1 p.m., the bank is sending SMS or the push location to your customers. We know that you are in this specific place. If you go, for example, upstairs 2 floors in the shopping mall, you find a restaurant. And if you order the lunch and pay with the bank credit card, you get 5% discount. So this is something as some kind of bonus discount proposal, which is driving both business on the ATMs, business on the credit card, and also based on the merchants POCs business. Also, in the second phase, the bank decided to run and use the signals coming from the Stream Analytics to detect potential fraud and monitor customer behaviors. And for example, if customer is trying to do some kind of major transaction on the credit card or doing some kind of real money transfer, this kind of signal is launching the rescoring of the credit scoring of the customer, recalculation of the credit scoring, and customer scoring is redefined, recalculated with respect to these recent transactions. Also, bank trying to implement the customer retention intelligence, trying to detect some kind of churn signals. For example, when the customer is looking on some kind of specific areas of the agreement, trying to find out what are the details of the agreement, or trying to make some kind of specific steps which are probably some kind of happy path or not happy path for a churn, the bank would like to act proactively and try to provide some kind of special proposal with the call from the call center, or some kind of special SMS, or some kind of special proposal through the mobile application to trying to avoid customer churn and trying to decrease the churn rate. And last but not least, the customer also would like to decrease the operational cost, because the Stream Analytics is mostly automation of the process, and majority of actions are driven by the automated business rules. In the communication with customers, when the number of the number of the communication is growing, majority of the communication is doing by the automates, and notifications and actions are automated, are used with some kind of specific rules and scenarios, and the bank would like to also use this automation to decrease the cost of the personnel to take care of these pipelines, these actions, and try to revive customer, for example, with the abandoned card. Last but not least, also would like to mention that this solution, as I said previously, and Alex showed in the presentation, is mostly designed for the business people without IT literacy, which means that to run some kind of changing very often analytics in the real time, people from the line of business of a bank are not forced to use IT guys and the experts with the SQL literacy, or some kind of analysts and the developers. They are doing this analytics themselves without participation of the high-skilled people, and doing it quite well after very short training, which is also some kind of good point for the bank to avoid trainings, avoid personal occupation and easiness of doing business with the people. At the end, if you have more questions regarding the project or solution, just please contact my friends in the US, Sylvia or Michael. As Mike said at the beginning, we are a strong partner for the Oracle for more than years. We have plenty of expertise within that Golden Gate and Stream Analytics and Exadata. So from this perspective, we are on your disposal for the more interesting projects. Thanks a lot for that. Mike, stage is yours.
With that, there haven't been a lot of questions that have come through Q&A, but if you have any questions right now, please put them in the Q&A. We've got a great panel here who can help you understand and answer those questions. If you don't have a question, you have our contact information. You can reach out to us. We'd be happy to invite you and Oracle all together and talk about your specific use cases, talk about proof of concepts to make sure that it works within your business environment. But I think now we're happy to spend some time answering your specific questions about Oracle Stream Analytics or anything you saw today. And I don't see a lot coming through. Let's go ahead and wrap it up then. Appreciate the time. I hope the information and the sharing of the demo was helpful in helping you think about how analyzing your data in motion and being able to make on-the-fly decisions in the moment change the way you do business for the positive. With that, we've got a new question. Let's see, it's an open question. So we already have BI and big data. Why would we need Stream Analytics? Alex, Pete?
So the BI, the traditional BI and Stream Analytics have each their own valid use cases. But when you see the traditional BI, which is based on batch data feeds and to reports that often cover a certain time period. So, for example, the weekly report, the daily report, that's very useful, but sometimes you need up to the minute information, like in the use cases we saw with banks wanting to provide personal offers right in the moment while the customer is at a point of sales. That cannot be done with a weekly report. That's something where you need immediate reaction. Same as fraud detection, inventory restocking, preventive maintenance. There are a lot of individual use cases where you want to react immediately. And it's becoming more and more relevant as we're reacting to immediate needs of customers, as the customers are contacting us, as we see something happening with the customers, that we need to react immediately rather than having it go through several steps.
And another question is Stream Analytics, Oracle Stream Analytics standalone, or is it required to be on Oracle Golden Gate or Oracle database?
It is standalone. It requires nothing, no other product from Oracle. It works based on Spark and Kafka, which are both open source, and you can use different commercial implementations of those. If you're using Oracle Cloud, these already come along with it. If you're running it on premise, you need to set up these environments, but you don't need any other. No Golden Gate, no Oracle database are required.
Perfect. And then one last question I see is, are there any industries, from an industry segment standpoint, have we seen where it works the best and where it might not be as applicable?
Okay, so we're seeing a wide variety of industries here. There's really no industry where it's not applicable. I mean, we see strong points in banking and financials. We see it in utilities, especially now with smart meters and a lot of automation where you have live data feeding in. We're seeing it at oil and gas. We're seeing it in retail. We're seeing it in a lot of hospitality environments and also in transportation. Both in railroads, we have quite a few customers in railroads. We have it in aerospace. And also one thing that we're seeing more and more is manufacturing, where customers need to automate special aspects of manufacturing. Often they have their main manufacturing systems, but on top of that, they can benefit from having little custom streaming solutions that can quickly be set up and be used in order to work with any kind of problems as they appear.
Excellent. Well, that's all the questions I see. We'll wait about 15 seconds here to see if anything else comes in. If any of those questions jog some additional questions. But once again, thank you for spending time with us today. And I hope the information was helpful. And if you have any questions, reach out to anybody on this panel. We'd be happy to go in depth on your specific needs and help you understand whether Stream Analytics is a good fit for you and your business. So thank you very much, everyone. Have a wonderful day.